Polly the Polynomial Penguin, back talking to you about multiplying polynomials, special cases. Now here's the question. What's easier to catch in a wintertime than a penguin? A cold!
First thing you're going to do is review foiling or double distribution. So here, remember, foiling stands for first, outer, inner, last. It's the order in which you multiply two binomials. So here we have a binomial x plus 2 and another binomial x plus 3 that we're going to multiply. So when you multiply using the FOIL method, first, we're going to multiply the first terms together. So that would be the x and the x. And when you multiply x times x, multiplying like bases, you add the exponent, so that becomes x squared. Then you multiply the outer terms together, that would be the x and the 3. So what's 3 times x? That's positive 3x. So you write plus 3x next to your x squared. Then you multiply the inner terms together. So the two inner terms would be 2 and x. So what's 2 times x? That's positive 2x. So you write plus 2x down here. And then what's 2 times 3? The last terms we're going to multiply together. So that becomes 6. Once you have done all that, you need to simplify or combine like terms. In this case, that would be the 3x and the 2x. When you add those together, you get 5x. So your answer should be x squared plus 5x plus 6. Again, if you want to think about it as double distribution, you're just distributing the x to the x and the 3. Then you're going to distribute the 2 to the x and the 3. That is how you FOIL or double distribute, however you want to think about it. Now, difference of squares. This is one of the two special cases we're going to talk about today. A difference of squares occurs when you multiply the sum and difference of the same two terms. So here you have a sum and a difference of the same two terms. A plus b times a minus b. Anytime that happens, you can use a shortcut to just jump ahead and say, well, a plus b times a minus b has to equal a squared minus b squared. And we'll do a bunch of examples of this to make sure you got it. But I also want you to know that if you forget the shortcut for some reason, you can always just FOIL and you'll get the exact same answer. And I'll show you that.
What did the penguin order at the Mexican food restaurant? A burrito! Example time!
So example 1, we're going to multiply x plus 5 times x minus 5. You see that they are the exact same terms, but one is a plus and one's a minus. One's a sum and one is a difference. So what we're going to do, we recognize it's a difference of squares that we're going to end up getting. What we want to do is just see, okay, what is my a value and what's my b value? Well, it looks like my a value would be x and my b value looks like 5. So all I have to do is now take these and plug them into this, a squared minus b squared. So it's going to be x squared minus 5 squared, or x squared minus 25. That's my answer. If you memorize the shortcut, that's how easy it is. If you forget the shortcut, all you have to do is FOIL. First terms, we multiply together. What's x times x? That's x squared. Outer terms, we multiply together. What's x times negative 5? Negative 5x. Multiply the inner terms together. 5 times x is positive 5x. And then the last terms together, 5 times negative 5 is negative 25. Then you combine like terms, the negative 5x and the 5x actually cancel each other out, and we're left with x squared minus 25, just like we got with our shortcut. Again, both ways work. Here, let's do both again. We have the same terms, one's a plus, one's a minus. Therefore, we know that this is going to be a difference of squares. So here we just have to figure out what's our a value and what's our b value. Well, it looks like our a value is 6s and our b value is 1. So we go ahead and plug these in over here. 6s squared minus 1 squared. Now remember, you're not just squaring the s, you're squaring the 6 also. So this is going to be 36s squared, and then 1 squared is just 1, so you're done. If you were to forget that though, just FOIL, just like you normally would. So we multiply the first terms together. 6s times 6s is 36s squared. Then you multiply the outer terms together. 6s times negative 1 is negative 6s. And then multiply the inner terms together. 1 times 6s is positive 6x. And then 1 times negative 1 is going to give you negative 1. We then combine like terms. These two in the middle are going to cancel each other out. And we're left with 36s squared minus 1, just like we got with our shortcut.
How do penguins take their drinks? With extra ice! You try.
Okay, so again, we're multiplying these two binomials. They are the same terms, but with different signs, so it should get you a difference of squares. So let's go ahead and do this. What we want to do first is figure out what's our a value and what's our b value. Well, it looks like our a value is going to be r, and our b value is going to be 9. So all we have to do is do r squared minus 9 squared, and that's going to be r squared minus 81. And you're done. If you forgot how to do that, all you would have to do is FOIL. So r times r, we multiply the first terms together, that's r squared. Multiply the outer terms together, r times 9 is positive 9r. Multiply the inner terms together. Negative 9 times r is negative 9r, and then negative 9 times 9, the last terms we multiply together and we get negative 81. Combine like terms, these two in the middle are going to cancel each other out, and you're left with r squared minus 81, just like we got with our shortcut. Here, we see same terms, different signs. So what we do is we jump to our shortcut, a difference of squares. So figure out what's our a value. That's going to be 4x in this case, and what's our b value? It's going to be 2. So now we just plug these into our difference of squares formula over here. What is 4x squared minus 2 squared? Well, 4x, remember we're squaring 4 and the x, so you end up getting 16x squared, and then 2 squared is just 4, so you're done. If for some reason you forgot how to do that, you just FOIL. Multiply the first terms together. 4x times 4x is 16x squared. And then you multiply the outer terms together. 4x times negative 2 is going to be negative 8x. Multiply the inner terms together. What's 2 times 4x? That's positive 8x. Multiply the last terms together. 2 times negative 2 is going to be negative 4. Combine like terms. These two in the middle are going to cancel each other out. And you're done. You get the same thing that you got with our shortcut. Okay, example 2. We're doing the same thing, except it's a little trickier this time. Again, we have the same two terms, but with different signs in the middle. So what we're going to do is we're going to use our difference of squares formula. What we get when we FOIL this all out should be a difference of squares. So let's try. With our shortcut, we see that our a value is actually going to be x times y. Our b value is going to be this 2y. Now, what I do is I take each of those, plug it into the formula over here. Xy squared, I have to square the x and the y. 2y squared, I have to square the 2 and the y. So this becomes x squared y squared minus 4y squared. And you're done. It's that easy. Please note, I didn't talk about this before, but you got to notice, when I'm picking my a value and b value, it doesn't matter what the sign is. Your a value and your b value are going to be positive. The minus comes in over here. And remember, if you forget how to do this, you can always just FOIL. We multiply the first terms together. xy times xy, well, you multiply the like bases, you add the exponents. So this is going to be x to the first times x to the first is x to the second. And then same thing with y. Y to the first times y to the first is y to the second. Then you multiply the outer terms together. So here, negative 2y times this xy. You're multiplying like bases, so the y to the first times the y to the first becomes y to the second. But the 2 and the x just say 2x, so it's going to be negative 2xy squared. Then you're going to multiply the inner terms together. So 2 times y times xy. You're going to multiply the y and the y, so y to the first times y to the first becomes y to the second, so you get positive 2xy to the second. Then you multiply the last terms together, so 2y times negative 2y is going to be negative 4y squared. Now you combine like terms, these two in the middle actually have the same variables to the same degrees, so we can combine those. The negative 2 and the positive 2 actually end up canceling each other out. So we're just left with x squared y squared minus 4y squared, just like we got with our shortcut. Here, same thing. We have two of the same terms in each of these, but one's a plus and one's a minus. So this is going to give us a difference of squares. So we have to figure out what is our a value. So in this case, that would be this 2x squared. And then what's our b value? That's going to be this 3. Again, we don't care about the sign. The sign takes care of itself at the end. So what we do is we then plug these into our difference of squares formula. So 2x squared goes in for a and 3 goes in for b. Now what is 2x squared? The quantity squared. Well, you have to square the 2 and the x squared. So 2 squared is going to be 4, and then x squared squared, a power to a power, you have to multiply those exponents. So you end up getting 4x to the 4th. Over here, 3 squared is going to be 9, and you're done. If for some reason you forgot how to do this shortcut, again, you could just FOIL, multiply the first terms together. 2x squared times 2x squared, the 2 times 2 gives you 4. And the x squared times the x squared, you add the exponents when you're multiplying like bases, so you get x to the 4th. Then you multiply the outer terms together. What's 2x squared times negative 3? That's going to be negative 6x squared. Then you multiply the inner terms together. What's 3 times 2x squared? That's going to be positive 6x squared. Then you multiply the last terms together. What's 3 times negative 3? That's going to be negative 9. Now combine like terms. This negative 6x squared plus the positive 6x squared cancel each other out. You're left with 4x to the 4th minus 9, just like we got with our shortcut.
What falls in the winter and never gets hurt? Snow! Wah, wah, wah. You try.
Okay, doing the same thing here. We have two of the same terms in each of these, and then we have a plus and a minus sign. That's the only thing different between these two binomials. Therefore, we're going to get a difference of squares. So what we have to do is figure out what's our a value and what's our b value. So it looks like our a value is actually going to be p cubed times q, and then our b value is going to be 8q. Remember, we don't care about the signs. So what we can do now is we can take this p cubed times q, plug that in for a, and we're going to take 8q and plug that in for b. P cubed times q, the quantity squared, we have to square each of those. So p cubed, if we square that, power to a power, we multiply, so it becomes p to the 6th power. And then q to the 1st, raised to the 2nd power, we multiply those, it's going to be q to the 2nd power. Over here, we need to square the 8 and the q, so you end up getting 64q squared, and that's how you do it. Super easy. Now, if you forgot that, you could just FOIL. We multiply the first terms together, p to the 3rd times q times p to the 3rd times q. When you multiply like bases, you add the exponent. So p to the 3rd times p to the 3rd is going to be p to the 6th, and then q to the 1st times q to the 1st is going to be q to the 2nd. Then you multiply the outer terms together. P to the 3rd times q times 8q. You multiply the q's together, so you get q to the 1st times q to the 1st is q to the 2nd, so we get 8 p to the 3rd q to the 2nd. Then you multiply the inner terms together. So again, q to the 1st times q to the 1st is q to the 2nd, and since it's negative 8 this time, it's going to be minus 8p cubed times q squared. And then you multiply the last terms together. Negative 8 times positive 8 is going to be negative 64, and then q to the 1st times q to the 1st is q to the 2nd. Combined like terms, these two in the middle have the same variables to the same degree, so we can cancel those out because they have opposite coefficients, and you're left with what we got when we did our shortcut. Here, same thing. Yes, they have the same terms with different signs. Therefore, it's going to be a difference of squares. Now we just have to figure out what's our a value and what's our b value. So it looks like our a value is going to be 7m cubed and our b value is going to be 2. So we go ahead and take those, plug them in over here. The 7m cubed we plug in for a, and the 2 we plug in for b. 7m cubed raised to the 2nd power, we're going to square the 7 and the m cubed. So 7 squared is 49. M cubed to the 2nd power, power to a power, we multiply, so that becomes m to the 6th. And then over here, 2 squared we know is 4. And you're done. So that's if you remember the shortcut. If you forget it, you can just FOIL. So multiply the first terms together, 7m cubed times 7m cubed, multiply the 7s together, you get 49. Multiply the m cubes together. When you multiply like bases, you add the exponents, so that would be m to the 6th power. Then you multiply the outer terms together. 7m cubed times negative 2 is going to be negative 14m cubed. Multiply the inner terms together. 2 times 7m cubed is going to be positive 14m cubed. And then multiply the last terms together. 2 times negative 2 is going to be negative 4. Combine like terms, these two in the middle have the same variable to the same degree, and since they have opposite coefficients, they're actually going to cancel each other out. So we're just left with 49m to the 6th minus 4, which is what we got with our shortcut. Next thing we're going to talk about is a perfect square trinomial. That's going to occur when you square a binomial. So here we have a binomial being squared. Here we have a binomial being squared. Each of these produce a perfect square trinomial. Again, this is just a shortcut of foiling each of these. Now, what I want you to see is that there's one difference between each of these. One of these binomials has a plus, one of them has a minus. One's a sum and one is a difference. And it changes one thing over here. If it's a plus b, the quantity being squared, then your first sign, the sign of your middle term, is going to be a plus sign. If it's a minus b, the quantity being squared, then your sign of your middle term is going to be a minus. The last term is always going to be positive. That's how you memorize these. These, again, are just shortcuts. If you ever forget the shortcut to get a perfect square trinomial, you just FOIL, and you'll get the exact same thing. Now example 3, it says multiply, and here we have z minus 9, the quantity being squared. Okay, so when you have a binomial being squared, that's when you get a perfect square trinomial. In this case, because it's a difference, it has a minus in the middle, we use the minus formula, which means it's going to end up being a squared minus 2ab plus b squared. What we do now, we figure out what's our a and what's our b. Looks like our a is going to be z and our b is going to be 9. Again, we don't care about the signs. The formula takes care of the signs for us. Now what we can do is plug in. So we plug in z for a here and here. Plug in 9 for b here and here. Then we simplify. It looks like z squared already simplified. 2 times z times 9. Well, the 9 times the 2 becomes 18, so it becomes minus 18z. And then lastly, 9 squared gives you 81. Let's say you forgot the formula. Let's say you forgot the perfect square trinomial formula. We can always just FOIL this out. Z minus 9, the quantity being squared, is the same as z minus 9 times z minus 9. And then all you have to do is FOIL it out. Multiply the first terms together, multiply the outer terms together, multiply the inner terms together, and then multiply the last terms together. Then you combine like terms. What's negative 9z minus 9z? Those don't cancel each other out. Negative 9z minus 9z makes it more negative, so it'd be negative 18z. And that's exactly what we got with our shortcut. Again, do it either way. Here, we have b plus 11, the quantity being squared. Since we have a binomial being squared, this is going to turn into a perfect square trinomial. Since we have a sum, we're going to use the sum formula, the one with the plus. So that just means both of the signs are positive. Sweet! Now we figure out what's our a value and what's our b value. Our a value is going to be b. Our b value is going to be 11. So we plug in b for our a here and here. Plug in 11 for our b here and here. I know it's kind of confusing that a is b in this case, but it's going to happen sometimes. We now simplify. B squared, done. 2 times b times 11. Just multiply the 11 and the 2, you get 22b. That goes in the middle, and then 11 squared is 121, and you're done. Sweet. Let's say you forget the shortcut. What you can do instead is just change b plus 11, the quantity squared, to b plus 11 times b plus 11. Then you just FOIL. Multiply the first terms together, the outer terms together, the inner terms together, and the last terms together. Then combine like terms, the 11b plus the 11b gives you 22b, and that's the exact same thing you got with our shortcut in the beginning.
What do you call a snowman in August? A puddle! Wait. Deep dive.
Again, doing the same thing here, we have a binomial that's being squared. Therefore, it's going to create a perfect square trinomial. Since we have a plus in the middle, we're going to use the formula with the plus. So it's a squared plus 2ab plus b squared. Now, we figure out what's our a, what's our b. Looks like our a is going to be x, our b is going to be 8. So we plug in x for a here and here. We plug in 8 for b here and here. Then you simplify. 2 times x times 8 is going to be 16x, and then 8 squared is 64. Sweet, all done. You got your perfect square trinomial. Let's say you forgot that though. You can always take x plus 8, the quantity squared, and change it to x plus 8 times x plus 8, and then FOIL. So let's FOIL. First terms, we multiply those together, you get x squared. Multiply the outer terms together, you get 8x. Multiply the inner terms together, you get 8x. Multiply the last terms together, you get 64. Combine like terms, what's 8x plus 8x? That's 16x. Again, the exact same thing we got with our shortcut. Either way. Here, same thing. We have a binomial being squared. Since it's a minus, it's a difference. This time, what we're going to do is use that formula, where it's a squared minus 2ab plus b squared. So what's our a value? That's going to be 3k. What's our b value? That's going to be 1. So now we plug in 3k anywhere you see an a. We plug in 1 anywhere you see a b. Now what is 3k, the quantity squared? Well, you square the 3 and the k, so you get 9k squared. Over here, 2 times 3 times 1. That's going to give you 6. And then over here, 1 squared is just 1. So now we have our perfect square trinomial. Let's say you forgot the shortcut though. You can always change this guy to 3k minus 1 times 3k minus 1. Then you just FOIL. Multiply the first terms together, multiply the outer terms together, multiply the inner terms together, and then the last terms together. Negative 1 times negative 1, positive 1. So we combine like terms in the middle. Negative 3k minus 3k makes it more negative, so it's going to be negative 6k. And that's the exact same thing we got with our shortcut. You can get it either way. Example 4, doing the same thing. We have a binomial that's being squared. Therefore, it's going to create a perfect square trinomial. Since it's a difference, we use that formula. Here, our a value is now going to be h to the 4th power. Okay, these are getting a little tougher. So a is equal to h to the 4th. B is going to be 12. So we're going to plug in h to the 4th anywhere you see an a, and we're going to plug a 12 in anywhere you see a b. Now h to the 4th, the quantity squared, power to a power, you multiply those. So this becomes h to the 8th power. Here, negative 2 times h to the 4th times 12 gives you negative 24 h to the 4th. And then over here, 12 squared is 144. And you're done. Perfect. That's our perfect square trinomial. Now let's say you forgot that. You could always just FOIL. Multiply the first terms together. So h to the 4th times h to the 4th is h to the 8th. When you multiply like bases, you add the exponents. Multiply the outer terms together, negative 12h to the 4th. Multiply the inner terms together, negative 12h to the 4th. Multiply the last terms together, positive 144. Now, combine like terms, these two in the middle, since they're both negative, makes it more negative. So negative 12 minus 12 is going to be negative 24h to the 4th. And it's the exact same thing we got as our shortcut. For part B, we have 7x to the 3rd plus 2, the quantity being squared. Again, since we have a binomial squared, it's going to create a perfect square trinomial. So we use the sum formula this one. So that means our middle term is going to be positive. Now what we do is we go ahead and figure out what's our a value. So it's going to be 7x to the 3rd. What's our b value? 2. So we're going to plug in 7x to the 3rd anywhere you see an a, and then a 2 anywhere you see a b. Now, 7x to the third, the quantity being squared. We square the 7 and the x to the third. When you do a power to a power, you multiply these, so it's going to be 49x to the 6th. Over here, we multiply the 2, the 7, and the 2 to end up getting 28. And then lastly, 2 squared gives you 4. Perfect. Done. We have our perfect square trinomial. Let's say you forgot this formula. Just change this to 7x cubed plus 2 times 7x cubed plus 2. You could then FOIL that out. If you multiply the first terms together, the outer terms together, the inner terms together, and the last terms together, and then combine the two middle terms, the like terms, you get 28x to the third power, which is the exact same thing that we got with our shortcut.
Why did the hot penguin put on sunglasses? To get cool! You try.
Okay, finishing up, same thing. Here we have a binomial that's being squared. That's going to create a perfect square trinomial. So we use the minus formula, the difference formula here. So that means our middle term is negative. Now what's our a value? C cubed. What's our b value? 6d to the 5th power. So we're going to take c cubed, plug it in anywhere you see an a, plug in 6d to the 5th anywhere you see a b. Now what is c cubed squared? Well, power to a power, you multiply those, so that becomes c to the 6th. Over here, negative 2 times c to the 3rd times 6 times d to the 5th. We've multiplied the 6 and the negative 2. You get negative 12 in the middle. And then over here, we're going to square each of these. So we square the 6, we get 36. Square the d to the 5th, power to power, you multiply it. That's why it becomes d to the 10th. This is a perfect square trinomial. And let's say you forgot our shortcut. Just FOIL. We turn c cubed minus 6d to the 5th squared into c cubed minus 6d to the 5th times itself. We then FOIL. So multiply the first terms together. When you multiply like bases, you add the exponents. So it becomes c to the 6th. Multiply the outer terms together. The inner terms together. And then the last terms together. Negative 6 times negative 6 is positive 36. And d to the 5th times d to the 5th, add the exponents, it becomes d to the 10th. Now you combine like terms in the center. Negative 6, c to the 3rd, d to the 5th, minus 6, c to the 3rd, d to the 5th. Makes it more negative, so it's going to be negative 12, c to the 3rd, d to the 5th. Same thing that we got with our shortcut. Over here, again, we have a binomial that's being squared. So what we want to do is use our perfect square trinomial shortcut. Since it's a sum, we're going to use that one where our middle term is positive. We then go ahead and make our a value x to the 6th y, make our b value 4. We plug in x to the 6th y anywhere you see an a, so here and here. Plug in 4 anywhere you see a b. Now, when we are squaring x to the 6th y, we square the x to the 6th and the y. So x to the 6th squared, power to a power, you multiply. So it's going to be x to the 12th, y squared. In here, we multiply the 2 and the 4, you get 8. And then over here, 4 squared gives you 16. This is your perfect square trinomial. Now again, if you were to forget that, just rewrite this as x to the 6th y plus 4 times x to the 6th y plus 4. You could then FOIL, multiply the first terms together. Anytime you multiply x to the 6th times x to the 6th, like bases, you add the exponents. That's why you get x to the 12th. And then y to the 1st times y to the 1st is y to the 2nd. Multiply the outer terms together, the inner terms together, and the last terms together. Then you can combine like terms in the middle. 4x to the 6y plus 4x to the 6y is 8x to the 6y, and it's the exact same thing we got with our shortcut. Now our word problem says a square deck has a side length of x plus 5 feet. You are expanding the deck so that each side is 4 times as long as the side length of the original deck. What is the area of the new deck? So step 1 in the word problem, we're not scared. We can do this. Step 2, we got to define our variables. So what are our variables? Well, in this question, what is it asking? It says, what is the area of the new deck? So we'll say A is the area of the new deck. Then the question is, what else? Well, it does say that the square deck has a side length of x plus 5 feet. Well, since it's a square deck, we don't need length and width. We just need one side because they're all the same length, right? It's a square. So we say S is the length of a side of the deck. Now, what does this look like? Anytime you can draw a figure for a word problem, do it. So here we have our original square deck where a side length is x plus 5 feet. It also says we now are making this bigger. We're expanding the deck so that each side is going to be 4 times as long as the side of the original deck. Now, if I wanted to figure out the side length of the new deck, all I would do is take the original deck and multiply that by 4 because the new side length is 4 times as long as the original. So if I were to distribute this and simplify, it would be 4x plus 20 feet. That's the side length of the new deck. So I'm ready now to write my equation. How do I find the area of a square? Well, technically it's base times height, but the base and the height are the exact same. They're just the same side length. So it's going to be whatever one of the side lengths is squared. So that's a equals s squared. And we said s is the length of the side of the deck, which in this case is 4x plus 20. So we plug that in for s. And we know how to simplify this now. This is going to create a perfect square trinomial. We have a sum that's being squared. So we just need to figure out what's our a value and what's our b value. So in this case, our a is going to be 4x, our b is going to be 20. And again, we're using the formula that has the sum, therefore our middle term, our first sign, is going to be a plus. So now we plug in 4x anywhere you see an a, plug in a 20 anywhere you see a b. So 4x, the quantity squared, we square the 4 and the x, you end up getting 16x squared. Over here, 2 times 4 times 20 is 160, and then 20 squared is 400. This is going to be the area of the deck. But let's say you forgot how to do that. You again could just FOIL this out. Multiply the first terms together, the outer terms together, the inner terms together, and the last terms together, and then simplify. You end up getting the area of the new deck is 16x squared plus 160x plus 400 feet squared. Again, area needs square units. Don't forget that.